Welcome to yet another podcast. Yeah, I would say a continued podcast with Dr. Yogesh Kulkarni. In the last podcast, we did see about what exactly analytics is. What are these terms descriptive analytics, artificial intelligence, machine learning, and how did Dr. Yogesh Kulkarni himself get into this field of analytics? What an interesting discussion that was. Now, we are going to continue the discussion with Dr. Yogesh. And those of you who do not know him, Dr. Yogesh Kulkarni is from Pune. He did his schooling here. He did his engineering from College of Engineering, Pune. Then completed his master's MS from US. And then for 20 years worked into the field of CAD-CAM and then got into this field of artificial intelligence, a big career transition, and he is still very active into that field. So let's continue our discussion with Dr. Yogesh. Welcome, Yogesh.
Thanks, Anand.
So it was a fantastic discussion last time. I remember that you told our viewers about what exactly this analytics is. And the most interesting part actually for me was anybody and everybody can come into this field of analytics. And by now, all of them who have decided to explore this, today's podcast, I would like to have some discussion with them.
Correct.
For rest, they can always refer to our podcast, the previous one. But I wish there was some sketch, some kind of drawing in front of me so that I could really take that to my viewers and help them talk about what are these steps one could get into analytics. If you could guide them step by step,
Correct.
is there a way we could do that?
Sure. And you said it right. So there is something called a sketch note.
Oh, really?
So apart from doing programming, I do sketching also.
Wow.
But this sketching is a little different. So what I do, I pick up a topic, and then in one page, I try to draw a few things. May not be a picture-like thing, but diagrams, so
Okay.
that a full topic can be summarized
Interesting.
into single page. So if you take a printout of it, then you have some ready reference with which you can plan your career.
Now I feel probably in your engineering, you probably needed only one notebook and you had all sketches in that.
Okay. So I do have a sketch note for how to transition to data science.
Okay.
So just search on Google my name and how to transition to data science. You'll get a blog
Okay.
plus this sketch note,
Awesome.
which you can refer, and probably we'll show it as here as well in this
Sure.
podcast. Yeah.
But my question was now what are those steps?
Correct.
Anybody who has decided that probably this is the field, analytics, AI, ML is the field I need to explore,
Correct.
then what are the steps they need to take?
Okay. So let me go back and maybe explain what kind of roles are there.
Okay.
So you're transitioning from your current domain, current role to this data science. So there are, in my opinion, there are three types of roles.
When you say roles, job roles, right?
Roles, yeah, functionalities.
Okay.
So you can be a user. So assume that you have some subject matter expertise. You're from pharma,
Okay.
you're from finance, but you don't have particularly a programming background. You have not done STEM, meaning engineering. You have not done mathematics, but you have good subject matter expertise. Okay. So for these guys, and even for managers who have stopped coding, okay,
Right.
those guys, a good role would be to go into a user level role. What do I mean by user? The user of AI.
Okay.
You're not doing programming, you're just using.
So like typically we said end users of a
End user.
system like that.
Software user.
Okay.
So you're driving a car, you're not developing a car.
Okay, got it.
You're a driver.
Yeah.
And there are multiple platforms available. So the platforms which are open source like Weka, WEKA, or Nime, KNIME, plus these popular cloud platforms, Google's, Azure from Microsoft, AWS from Amazon. All these guys have typically what is called as AI Studio.
Okay.
And that has a very drag drop, low code, no code functionality. If you want to do regression, some prediction, you drag data source, you drag prediction algorithm, you drag visualization, and then you connect the blocks, there you go. So you are doing machine learning, but you are not coding per se, at least at the initial level.
So you are the user of that.
You are the user of the software.
Right.
So that way, and even whatever latest technologies that we are familiar with, generative AI, prompt engineering that way is also user level. You are not coding anything per se, right? So prompt engineering is also user level. So if you have subject matter expertise, but no programming and no mathematics background, user is the level.
Okay.
Next level is developer level. Okay, there you have to have a programming background. Okay, so, people like me, I had programming background. So those guys, what they do, they will develop apps. You are designing a car now. Okay, that way. So you are developing apps using programming languages like Python or whatever, and then some libraries. So for a domain, say finance, pharma, whatever, you're developing apps. So you're a developer level. So there you need programming. So I had programming background in C, C++. Transitioning to Python was relatively easy. So it's a developer level. And third one is more rare and more complex. There you have to have mathematics.
Okay.
And that level is researcher level.
Okay.
The guys who develop these libraries, who write these libraries.
So user, developer,
And
researcher.
researcher.
Okay.
These guys will write or invent new activation functions, new neural networks. By the way, everything boils down to mathematics at the back end. So these three levels, depending on where you come from, you can choose these levels and then enter into data science.
Fantastic. So these are the steps now, and I'm sure these are visible from your sketch as well.
Correct.
So you need to identify yourself into one of these roles,
Wonderful. Correct.
or we can transition into the upper levels.
Yes.
So now you know I am a user.
Yes.
Can I develop what I used?
Correct.
And can I be a researcher to even decide what needs to be developed?
Correct. Correct.
Awesome. Okay.
yeah.
So you would get a path as to what you need to do. Fantastic. Now tell me one thing. You mentioned a little bit about maths just now.
Correct.
People would get scared. So some people are really good in maths, but they have not studied maths as such. Like they have not given a degree or some examination about maths. Some are not exactly programmers, but they have a programming mind because they could figure out something what kind of algorithms.
Correct.
So logic. So I know in what sequence if you do certain things, then you end up repeating that over and over again.
Recipe. Yeah.
Yeah, fantastic. So programming, algorithms, and maths is what I heard. Is this really required? I mean, my point is, I am like all excited now to get into this field, getting excited, getting ready, but scared of these three terms.
Correct.
So could you please tell a little bit about how you make yourself familiar with these?
So as I said, there are three levels of roles. For user level, you may not need mathematics. As I said, no programming also. So these three things are typically needed for developer level. I have mentioned this because I transitioned that way. So I became a developer of AI. So for that, you need three things. We'll just probably expand that. Okay, right?
Sure.
So mathematics, software development, meaning programming, and then of course algorithms, machine learning or deep learning related algorithms. Let's double click on each of them.
Okay, sure.
So in mathematics is actually a very vast thing. But what is more relevant to machine learning and deep learning, we'll see that. Typically, again, three things are needed. The most important thing is statistics.
Okay.
Some of the machine learning techniques like regression are actually statistical techniques.
Right.
So a good background in statistics, meaning what? Average, mean, mode, you should be very, very familiar with these terms.
Yeah.
And then many such things. So statistics, then there is something known as linear algebra. And that is nothing but what is called as vectors and matrices.
Okay.
If you have done matrix multiplication, if you have done vectors, cosine similarity, if these terms sound familiar to you, then you are in for this.
Okay.
So statistics, linear algebra, and third thing is calculus.
Okay.
Calculus is nothing but, anybody? Derivatives, integration, those things. Meaning given a curve, can you put a tangent? Or things like velocity or acceleration. These are derivatives.
Okay.
these things are needed to understand the machine learning related concepts. So that's the mathematics part. Machine learning is actually software development also. So you need basic fundamentals of software development for sure.
Okay.
Meaning, again, there are three things: uh, programming, language.
Yeah, because you need to finally, your code
You
will
have to
run
code
into
it,
that
right?
environment.
You have
Yeah.
to code it.
Yeah.
So typically, popular languages are Python and R. I'm slightly biased towards Python. I've done R, but I'm more familiar with Python because uh, there are religious wars. But still, Python has a bigger ecosystem.
Okay.
That's why, and it's easy to learn.
No, but
So
whatever it needs to learn, I mean, you need to take
you
it
need
up,
to,
and basically, if you want to start coding, then
correct.
language is required.
And then if you are a C, C++ programmer, learning Python is actually unlearning more. It's a more simplified language in my opinion.
Correct, correct, correct.
So programming, in software development programming, second is data structures and algorithms. That is not going anywhere.
Okay.
So DSA, being a software development thing, this is needed.
Okay.
And little higher thing would be needed is this design patterns also. All these standard software development aspects are as is, even if you are in data science, machine learning, and deep learning. So we saw mathematics, software development, and third thing is actually machine learning or deep learning related algorithms.
Right.
I'll just name a few.
Sure, sure.
Yeah. So in machine learning, typically you have set of algorithms which you have to learn. First is called as regression. Regression is nothing but predicting a continuous variable. This term is a little mathematical, but still it is like a float.
Yeah.
Predicting. Then there are algorithms, set of algorithms for classification.
Right.
Whether it will rain tomorrow or not, binary classifier, something like that. And third thing is clustering, how to group things. Further distinctions like supervised,
People say like,
unsupervised.
I want to do market basket analysis.
Wonderful.
And this sounds like a typical English word, but there is clustering behind it.
Clustering behind it. There are other methods also, reinforcement learning, a priori methods and other methods, but roughly these are the ones.
Okay.
And in neural networks, basically there are a set of algorithms like normal neural network or simple neural network, ANN, artificial neural network.
Right.
Then there are CNN for images. Typically for images, convolution neural network, RNN, recurrent neural network, many neural networks are available.
Okay.
So these things would be needed.
So here you are not a researcher, you are just trying to know what is already available.
Correct. These things would be needed for even a user, at least conceptual understanding. Because if you're predicting whether it will rain tomorrow or not, means you are doing binary classification. That you have to know,
Right.
Even if you are doing low code, no code, drag drop kind of thing, that conceptually
Which algorithm can be used, where is what you need to know.
what you have to. You may not understand the mathematics behind it. That's fine.
Right. Now, talking about all this, how easy or difficult it is. So, meaning my current step-by-step flow when you were talking goes that, okay, at least let me have a simple English discussion with you about what is, say, market basket, meaning clustering algorithm.
Correct.
Now, we can talk about it and I would get the concept behind it.
Correct.
Then possibly I would want to know which data structures go with it, or which programming or which logic. And if I feel that I belong to this area, then I can code it.
Correct.
So is it that simple, and it will probably take couple of months or something?
Absolutely. The recommended step is you have to know these concepts for sure. You can do some initial level courses for it, just to understand few things. But then I would suggest to pick up a problem, typically from your domain, and then try to apply these concepts there.
Okay.
Maybe we can do one example. Is that okay?
Sure. Yeah, that will be even interesting.
Correct. So as we saw previously, there was something called as rule-based or normal software development,
Right.
where you will take inputs, write logic, return the output. Right. That's the rule-based development. Then came machine learning, which uses data.
Right.
And then labeled data, annotated data. Then we saw deep learning, which uses neural networks. And then the current fashion, generative AI, prompt engineering. Let's take one example so that things are very clear.
So you mean to say the example would stay common across all these words?
Absolutely.
Wow, interesting.
So same problem can be solved by all four of these methods.
Awesome.
Why I am saying this? It's just one aspect is to show you progression, how things differ.
Okay.
But even in this so-called era of generative AI or prompt engineering or chat GPT, we still use rule-based. We
Okay.
still use machine learning. Because there are pros and cons of each.
Okay.
So let's take one example.
Absolutely. It almost feels like you're going to tell me some story.
Correct.
And stories reveal so many aspects.
Correct.
So something is about to happen now. Okay, tell me the example.
So a very popular example, say I'm a company, I have a product, and that product is in the market.
Okay.
And in social media, people are talking good about it as well as bad about it. And people are complaining and are praising.
It's something like what you call sentiment analysis.
Sentiment, wonderful. That's
Wow.
the term people
So like
use.
the nation wants to know that kind of thing. Okay.
Correct. So that's sentiment analysis.
Okay, sure.
For simplistic, we'll say if it is positive sentiment or negative sentiment.
Okay,
And that's
okay,
not
got it.
neutral and other shades of it. So you have product in the market and you have product reviews available on different sites. And you have got them.
Right.
Now your job is to analyze them and see how many positive reviews are there, how many negative reviews are. Simple.
Right.
If there are more positive reviews, your product is doing good.
Going.
And this is very much needed as a business, because if there are negative reviews, you have to change the product, right?
Absolutely.
That way. So it is a ROI kind of return on investment kind of app that you are building. How would you do this problem in a rule-based way? Given a text, some review, how would you calculate? How would you write logic to say that this is a positive review or this is a negative review? Any clues?
So like if I hear things like good
Wonderful.
or great, then probably it might be going on the right track.
Simple and crude logic is find all the positive words, add them. There are 10 positive words, 5 negative words. Overall, this is a positive review. Simple logic. This is rule based.
Okay.
How would you do that in machine learning? Or how would you do the same problem machine learning way?
That is getting interesting now.
Correct.
So you would possibly start applying how come a particular method is figuring out things possibly.
Correct. So for basic tenet of machine learning, that you have to have data. Meaning you have to have some past annotated data. Meaning you have to have all the records of previous product reviews.
Okay.
And their labels also. This is positive review, negative.
So somebody needs to mark that.
Anything past that is already done that.
Right.
People have, what is data is actually past. So if you have what is called as labeled or annotated data, now you have to just take that data, all the reviews pairs, review and its label, positive, negative, and supply to some classifier algorithm in machine learning.
Okay.
And it will train itself. And it will find correlation on its own. That's machine learning. That's the power of machine learning. And it will build a model to which, if you give any unseen review, it will predict.
Awesome.
Positive
So instead of saying that this rule, you do this, if this is good, why is this good? Something like that.
It will find out in its own.
Yeah, the algorithm will find out.
Given pairs, review and label, review, it will find out the correlation internally by some means.
Okay. Okay.
So this is machine learning way. And there are techniques like classifiers, support vector machine, naive Bayes, many such algorithms. Same thing, same training data. If you are using neural network, that's deep learning. That's about it.
Okay.
There is not much difference. Of course, what it does, here you need not do feature engineering. That's a little technical term, but for now, let's assume with the same training data supplied to neural network, which is again a classifier.
Okay.
It is deep learning.
Okay.
And the fourth one is, of course, generative AI.
Right. That's the current.
That's the current famous thing. So there, what you have to do, you have to write prompt. In the prompt, oh, these are the product reviews, this is my product. This text, does it sound positive or negative? You ask a prompt like that itself to ChatGPT or Claude, to any other chatbot like thing.
So we don't decide, we ask.
We ask. and the model itself, the model that is used in ChatGPT, so GPT 3.5 or 4, is smart enough to analyze the text and give you answer there and there itself.
Okay.
No neural networks, no classifier, nothing. Ready answer.
But I'm sure then this prompt thing must also be storing data somewhere, right?
Yeah. So prompt actually is nothing but you are talking to that model behind, and that model is trained on almost world public data,
Great.
and there they have seen the reviews. So with that idea, it is trying to answer. So with all four techniques, you can solve the same problem.
This is really getting interesting.
Correct.
So I feel that, and I feel this is not boring to just only learn coding. This is application. What you're just telling is application. Talking about applications, could you relate this to any job roles? What is happening in the market? And if I learn this,
Correct.
which kind of jobs? So that's my prompt question to you.
Yeah.
Which job roles could one start aiming at?
Correct. So as I said, jobs also come in these three levels.
Correct.
Roughly. Of course, their titles could be very different. User level, managerial level. There you have to have subject matter expertise plus understanding of AI. That's one thing.
Okay.
Second is developer level. You're a software engineer, but for ML. So there's an ML engineer, ML architect, those kinds of things. And research is also, of course, more research-oriented mathematics level job roles. That could be probably architects, senior architects, but doing really core work.
Okay.
So in job description, you can find out where out of these three, which is the matching to. Are you expected to do software development or just managing a ML team, or you are supposed to do research in ML? So that way you can say there's another dimension to it also. What is the data on which you are working?
Okay.
So typically when we say data, we assume that it's some numbers in some tables.
Right.
But that's not data alone.
Okay.
So even text is data. Even sound files are data. Even videos are data. So whatever is storable,
Anything and everything which can be stored in your machine is data.
Is data.
Awesome.
So and typically all these algorithms actually work on numbers only. So for numerical problem, like predicting whether it will rain tomorrow or not, what you need, some temperature, pressure, humidity, those things. That these are numbers. So predicting that is a normal standard numerical prediction. But the product review thing is not actually numbers, it's text.
Correct.
So there are many techniques in NLP, natural language processing, where you convert text to numbers first. And there are many techniques for that. And then you apply machine learning and deep learning.
Awesome.
So that's the way. If you are doing sound analysis, image analysis or video, they're actually internally numbers only.
Yeah, because you store it as.
Correct. But depending on your domain, whether it is a numerical problem, image problem, video problem or language problem, these job roles could be different. So that's how you can see in the job description, is it really suiting you or not? Plus, of course, one more dimension to it, is it being applied for pharma? Is it being applied for fintech or agriculture domains also? So multiple things can be seen in the job description and see where you fit in.
So great. So if one starts learning this, then possibly you should be able to read the job description.
Absolutely.
Is that correct?
Absolutely.
Okay. So now I'm getting comfortable. Correct. Now I know I have learned, I have started doing some kind of applications there, and now I can even read the job descriptions.
Correct.
Just before that, can anybody, if somebody doesn't want to leave their job,
correct,
are there projects available like you go on a website and you get data and you start applying your knowledge? Is that possible?
Correct. Very much possible. So as I said, probably I covered that in the first episode also, but I'll summarize that.
Okay.
Assume that you are doing a development role, developer role. So you have to have some foundation. Mathematics, programming and normal machine learning or deep learning algorithm. That you have to have across the domain.
Right.
But then you should try yourself throwing into different data types. Try some image level problems. Like in medical, you have X-ray analysis problem. It's an image-based problem. Pedestrian detection.
Right.
So many image-related problems. So that is one domain you can try. You can try text-related problem, NLP, natural language processing. You can try video-related thing, numerical things. I would suggest try all these domains.
Okay.
Okay. See where you are more comfortable. For me, it was text. So I drove deep into NLP, natural language processing. And where would you try this? Kaggle. Kaggle has competitions for all these data types.
Awesome.
So try all these data types, try competitions, see where you can grasp well, your leaderboard things are more.
Okay.
Choose that and then match it to your job description. Then you will find NLP related libraries in the job description.
Okay.
Similar techniques. Then it is natural fit. Plus, you have more comfort for applying to such, say, NLP specific jobs because you have done some work,
Yeah.
you have got a good Kaggle ranking, some POCs with
So
you,
you have learned something while you are doing something. That's
and then
great.
you can talk about it in the interview.
Awesome.
That way you can match the job description.
So that's a great hint actually, and it's just there. You have to just go and start learning over it. Thank you so much, Yogesh. This is actually helping every serious, I would say, either user or developer or researcher to get into the field hands-on.
Correct.
So thank you so much. Now I have this one last thought in mind. Is it required to leave what you are doing, learn, and then only you get into the new field? Okay, that's the final question because now everybody must be really eager to learn.
Correct.
But I feel that you don't have to leave what you're doing. If you are earning some bread and butter,
Correct.
and you want to explore something, you need not leave everything. What are your suggestions?
Absolutely. And I'm talking about a very typical case. Of course, if you have made crores, then you can think about it. But still, a normal case, I would strongly suggest not to leave your job.
Okay.
You can always learn these foundations, mathematics or programming or even machine learning algorithms. There are ample online, offline courses available.
Okay.
YouTube is full of such videos, playlists available.
Okay.
With small amount of fees, you can do this. So do this side by side.
Okay.
Don't leave your job. Don't leave your domain. In fact, I will go further and say, once you have mastered these algorithms or other machine learning or deep learning related technique, maybe apply one of those to your job problems itself if you have data.
Okay. Okay.
Maybe demonstrate it to your manager. There could be a possibility where in your organization itself will get transition to data science department, AI department, or make it a promotion also.
Awesome.
You don't have to even leave your job.
Great. I think there are a lot of hints coming from you, a lot of suggestions, and this is really, really encouraging for all our viewers. Thank you so much, Yogesh. I think this is just one step ahead for those who really want to get into this.
No problem.
Thanks,
Thanks, Anand.
Thanks. So viewers, this is really, really exciting. You not only just learned what this field of analytics, AI, ML is, but now in this particular podcast, you also know the exact steps. So while you are getting interested into it and you are getting to know a lot of terms, you are also getting to know what is the steps, what are these steps which will take you into that field. How do you apply those? How do you get to see these job descriptions? How you feel comfortable most importantly, and then you enter the field so that growth is the only resultant. So welcome to this world of analytics.